Good morning, everyone. I'm Brock. So today let's keep working on a LeetCode quiz, and we choose a category algorithm. Let's get a random question. This is a hard level question, so let's skip this one. This is a medium one. That's good. So let's look at the medium increments to equalize leaf paths. You are given an integer n and an undirected tree rooted at node 0 with n nodes, numbered from 0 to n minus 1. This is represented by 2D array edges of length n minus 1. Well, edges I equals to ui vi indicates an edge from node ui to vi. Each node has an associated cost given by cost I, representing the cost to traverse that node. The score of a path is defined as the sum of the costs of all nodes along the path. Your goal is to make the scores of all route to leaf paths equal by increasing the cost of any number of nodes by any non-negative amount. Return the minimum numbers of nodes whose cost must be increased to make all route to leaf paths scores equal. Let's look at the example. Input n is equal to 3, which means we have 3 nodes. And edges is 0, 1, 0, 2. Means that there is a path between node 0 and node 1. Node 0 and node 2. Cost is equal to 213. Means the cost to traverse that node. It's kind of like, a bridge toll, right? You pass a bridge, you are charged. So the cost of node 0 is 2, cost for node 1 is 1, and cost for node 2 is 3. And the passes from root to leaf is from 0 to 1, 0 to 2. And these passes, the cost is 3, 5. So to make all root to leaf passes score equals to 5, we need to increase the cost of node 1 by 2. So the output is 1. Okay, I think that it is straightforward, right? And maybe we can think about the main idea. We want to the main strategy we want here. So firstly, I think that we need to traverse the tree to compute all root to leaf passes sum, right? So the first part is traverse the tree to compute all root to leaf pass sums, right? Then what do we need to do? We need to find the maximum pass sum, right? Because that will be the target. Find the maximum pass sum. Anything else? Then for each pass, we need to increment node costs, right? Minimum to reach the maximum sum. So I think that's the main steps we need to do, right? Okay. So let's make a dictionary first. Project. And then what we need to do? As I mentioned, we need to traverse the tree, right? So for UV in edges, edge is a list, and each element of this list is a list. So let's get so let's put the destination node to to put the destination to the start point node. And passes, that's to make an empty list. And the next thing we need to do is we use a DFS, right? To traverse the whole tree. We need to know the node, we need to parent, pass, the total cost, right? So we need to put the pass, put the node in the end of the pass. And then let's check whether it's a leaf node or not. So and for the nodes, if the neighbor is not parent, right? If it's not parent, then it's not leaf. And the recursive node has the cost, right? And if we find the leaf, then we put the node at the end of the path, right? And we use a list here. And we pop out the path. We start from the root, right? So the node is node 0. It doesn't have parents, and the path is nothing here, and the cost is the cost itself. Let's okay. So then the second step is that we need to figure out the maximum, right? Then we use maximum to total. Passes, right? We need to calculate the maximum total in passes. Then we need to figure out, which elements need to be incremented, right? Increment nodes. And for pass total in passes, if the total cost is smaller than the maximum, Then we know we need to change the cost of the last node, right? Then we need to change the cost of the last node. Right? Then we return the length, the increment nodes. Let's quickly review our main steps. The first step is that we use DFS, depth first searching, to traverse the whole tree. The second step is that we need to figure out what's the maximum cost. The third step is we need to figure out how many passes smaller than the maximum passes. Let's try to run it. Okay. There's something wrong with my let's review it from the beginning. What's wrong? So first thing, we make a dictionary to store the tree. And for each edges, we put the edge in the tree. Then we initialize the path. Then we began to write a DFS function. Put the node in the path. If it initialize the indicator is live, then for the label, we will see where the label, if the label is not parent, which means it's not the live. If it is not the live, we call DFS here to achieve recursion. And if it is a live, then we put the path into the path list. Then we pop out the path. And then we need to calculate then we start from okay. I think that maybe because maybe I do the indication wrong again. Let's try to run it again. So the bug is pop from empty list. So which means that it doesn't do any initialization, right? So the path is empty. Line 35. And then you trace back to 930. And trace back to 31st, 37. And trace back to 81st. 81st is not in my code, so it doesn't show up here. Okay, so even if this is a real one, right? I think that I can ask again. I don't think that in a real interview we will be asked to run it in real time. But if there are some, get stuck somewhere, we still should be able to, to share our doubts or confusion with the interviewer. And here, because we don't have an interviewer, right? So let's say how ChatGPT think about. Oh, it's about the indentation again. Because, okay, so because the checking is, the checking is after the loop. I try it again. runs again. So it seems that the issue is more than the indentation. Oh, yeah, because I'm trying to add, increment the okay. So that's the issue. I'm trying to okay. To add the yeah, the end, but it doesn't work. So I guess one more comment is that we should use post-order DFS, right? Which means for each node, make all its subtrees has sums equal by incrementing child nodes, then propagate, right? Because previously we just add the next node, but sometimes adding intermediate nodes can also achieve our goal. And then count increments only where leaded, right? So let's review the whole logic. Initialize the tree is fine. Put the edges into the dictionary is fine. Let's comment out them first. From here. We need to define DFS again. Who is node, what is parent, and define resource. then calculate the sum, right? And then we do the traverse. So for the neighbor, basically the next node, right? In the tree, if the neighbor is not parent, which means it's not live, right? Then we calculate the child's sum. If not child sum, then we return cost. And the maximum still is the child sum's maximum, right? For the child sums, if something is smaller than maximum, then we know we need to update the path. And the cost is the node cost plus is child, right? And the DFS is we start from 0, which is a root. Parents is parent it's basically the node. So what we want to return? Oh, the same button indentation. Yeah. So the basic idea is we use post-order DFS. Increment only where child path sum is less than max. And the time is n on. The space is also on. So this ensures minimum cost incremented, including internal node. I tried. Still wrong answer, huh? Okay. Output none. I guess that it must be cause some, yeah, here. Yeah, I guess that's the point where I don't like a Python. You know, one of the parts of Python is that because it doesn't use brackets. Well, it's called brackets, right? It's called left brace, right brace. Curly braces. Yeah, I think that because we don't use curly braces, so it's very easy, feel confusing. about the indentation, right? Especially when one more. No. Yeah, I guess it's here. The return is DFS. Okay. Try it again. Okay. The local variable is used before it's assigned. Mm. 25. Local variable references before assignment. Oh, okay. Syntax error. I guess because non-local only works inside the nested function. So we need to move rest to be a mutable list. So that we can update it inside DFS without non-local. Let's make it a list here. So then we don't need this. Child sums not defined. Oh, typo. Oh, resource. It's a list here. When we return, we cannot return. What we return is not yeah, it's not a list. It's the element in the list. Let's see. Okay, cool. Accepted. And yeah, I think that's pretty much of it. Thank you.